Okay, hello everybody. So today we're going to begin our discussion in Chapter 4, Section 1. And in Chapter 4, Section 1, we are going to begin talking about what are called rational functions and also their asymptotes. So here's a few different objectives that we will hopefully learn while we're studying this chapter and section. We're going to find the domains of rational functions. We're also going to find the vertical and horizontal asymptotes of graphs of rational functions, and then use those rational functions to model and solve real life problems. So the first thing we have to familiarize ourselves with is what an actual rational function is. If you recall, a rational number is a number that can be written as a fraction. So that would include any integers or whole numbers, such as like 2, because you could write 2 as 2 over 1. But it would also include all the numbers like 2/3 or 3/4 or 7/8, things like that. Those are rational numbers. Well, we can have functions that are called rational functions because they are in the form of a fraction. And what you'll see is you will have an algebraic expression up here in the numerator, and then you'll have usually a different one down here in the denominator. And when you have them stacked like that, that is what creates what we call a rational function. Now, in general, the domain of a rational function of x includes all real numbers except for the x values that cause the denominator to equal 0, which we will take a look at here in a second. Much of the discussion of rational functions will focus on their graphical behavior near the x values excluded from the domain. So what we want to do for the first part is it says find the domain of f of x equals 1 over x and discuss the behavior of f near any excluded x values. So looking at our first function that you have right here, we have this f of x equals 1 over x. You can clearly see that there is a numerator and a denominator to this function. So this would classify as a rational function. The next thing that you need to notice is that we are not allowed to have the bottom of a fraction equal 0. So in this case, the value for x right here, x cannot equal 0. Otherwise, you would get an undefined value. So what does this graph look like, or what does this equation, I should say, look like when it's graphed? Well, as x approaches 0, if you look in this table here, we have first an x value of -1, then we go to -0.5, and then -0.1, and you can see the x values are getting smaller and smaller and smaller. They're approaching 0. They never actually reach 0, but they get really close. But what we want to see is what happens to the y values as our x value gets closer and closer to 0. And what you see here is as the bottom of the fraction, remember we're dealing with 1 over x here, as these x values get smaller and smaller, the y values are getting larger and larger and larger. So the outputs of this function get bigger and bigger. And what happens is this graph starts to approach from the negative side, negative infinity. In a similar fashion, as the x values start from 1 and then get closer to 0, the y values get bigger and bigger and bigger until they approach infinity. Now again, they can never equal infinity, but they're approaching infinity. So when we look at the graph of this, this is what we see. We have a graph that as the x value comes from negatives and it gets closer and closer and close to 0, it's going to go down really fast like this. In a similar fashion, when we start over here at 4 and then go to 3 and then 2 and then over to 1 and then we go up like that, the y values are shooting up really fast. Now they will never touch this line right here, the y-axis, which we're going to talk about. That y-axis is in fact one of the asymptotes of this function. The other asymptote would actually be the x-axis. As you can see, as this graph goes out, it gets closer and closer, but it never actually touches the x-axis. Now, you heard me use that word asymptote, and we've kicked it around a little bit. I've shown you some examples throughout the school year of what an asymptote is, but now we're going to specifically talk about them and why they happen and how to find where they will be located within a graph. So In example 1, the behavior of f near x equals 0 is denoted as follows. And you can see as f of x approaches negative infinity, then x would approach 0 from the left. And I actually don't particularly care how they write this. I would personally write this the other way. I would have as x approaches 0 from the left, the y value, f of x, approaches negative infinity. I like that better because we're referring to which way we're going, left and right, and then it tells us whether the graph is going up or down. In a similar fashion, this other one, I would rewrite it as well. As x approaches 0 from the right, then the y values will approach infinity. Now, if we look at the graph here, as I approach 0 from the left, you can see the graph is going down to negative infinity. As I approach 0 from the right, you can see the graph is going up to positive infinity. And that's what that notation is saying. These little minus and plus tell us which direction we're approaching 0 from. When we're in negative, that means from the left, and when we have a positive there, it means from the right. It says the line x equals 0, which is right here, right smack down the middle on top of the y-axis, is a vertical asymptote of the graph f. Now, there is also a horizontal asymptote, which is y equals 0, and that one occurs right here across there. So let me show you how to find asymptotes. So there are two ways to find asymptotes because there are two types of asymptotes. There's horizontal asymptotes and there are vertical asymptotes. Now, what we have right here are definitions of a vertical and horizontal asymptote. It says the line x equals a is a vertical asymptote of the graph of f when f of x approaches infinity or f of x approaches negative infinity. And then the second definition says the line y equals b is a horizontal asymptote of the graph of f when f of x approaches b as x approaches infinity or x approaches negative infinity. Now that may seem a little confusing, but let's take a look at a couple of graphs and it might help here a little bit. So you can see this first graph that we have here in part A is very similar to the graph that we just got done looking at in example 1. But this graph, as it goes to the left, starts to level out. And as this graph goes to the right, it also starts to level out. So what it does is there is a asymptote right here. There's a horizontal asymptote. And that horizontal asymptote is where the graph approaches as it goes to negative infinity and as it goes to positive infinity. So it's the number that the graph is approaching. Now, the other type of asymptote you can see here is a vertical asymptote. And that asymptote occurs when the graph steeply goes up or it very steeply goes down. And it won't cross over this line, though. And so what you end up getting there is a vertical asymptote. Now, in the second graph, you can see there is a horizontal asymptote. This one does not have a vertical asymptote. The reason why it has a horizontal asymptote is if I would extend this out further, you can see this graph begins to flatten out, and it flattens out right along the x-axis, which is y equals 0. Now, the last graph, you can see not only does it shoot up really fast like this and approach this vertical asymptote right here at 1, there is also a horizontal asymptote right here on the x-axis because the graph flattens as we go left and right. So those are just some examples of asymptotes and then showing you what graphs look like as they approach the asymptotes. So now let me show you how to find them, because that's really the most important part. Now, they are two different procedures for finding horizontal and vertical asymptotes. The easiest one to find, in my opinion, is the vertical asymptote. And so if you look at this first one, it says the graph of f has a vertical asymptote at the zeros of d of x. Now, what are they talking about there? Well, if you look and you can see d of x right here, d of x is the algebraic expression that is on the bottom of the rational function. So whatever number makes the bottom equal to 0, that number will create a vertical asymptote, whatever, or there could be more than one number that makes the bottom 0. Now, for horizontal asymptotes, we actually have to look at the degree of the numerator and the degree of the denominator of our rational function. So remember, the degree is simply the highest power of the algebraic expression that we have between all the terms. So it says when n, so if you notice, the degree of the top is n and the degree of the bottom is m. So when n is smaller than m, so when the top degree is less than the bottom degree, then it will have a horizontal asymptote at y equals 0. Now, the second case that can happen is if the degree of the top and the bottom are the same. Now, let me back up for a second. What am I saying when the degree of the top is less than the bottom? So if you had something like x squared over x to the third, you can see that the top degree is smaller than the bottom. Therefore, this function, if I made it y equals, would have a horizontal asymptote at y equals 0. Now, the next one for part B, it says when n equals m. And so if you had something like y equals 3x squared over 7x squared, you can see that the powers in the numerator and the denominator are the same. When they are the same, you actually have to take the ratio of the two leading coefficients to know what the horizontal asymptote is. So in this case, the ratio would be 3 over 7. So there would be a horizontal asymptote at y equals 3/7. Now, the last scenario is if the numerator is larger than the denominator. So if you had something like y equals x to the fourth over x to the first, then 4 is bigger than 1. So there would not be a horizontal asymptote for that. So kind of recap, right? So the denominator, when the denominator equals 0, that gives us a vertical asymptote. The horizontal asymptotes come from looking at the powers of the numerator and denominator. If the numerator is bigger than the denominator, there won't be one. If they are the same, then you have to divide the two leading coefficients. And if the top is smaller than the bottom, then it is y equals 0. So let's take a look at how to actually find them. So we're going to put into practice what I just told you. So we have two functions here. We have f of x equals 2x divided by 3x squared plus 1. So we want to find the vertical asymptote, and then we want to find the horizontal asymptote. So those are two separate procedures. The vertical asymptote is very easy to find. You literally do the same thing every time. You take the denominator and you set it equal to 0. So we're going to set 3x squared plus 1 equal to 0. And then I'm going to solve it. So I solve it by subtracting 1 from both sides, and then I divide by 3 on both sides, and I get x squared equals negative 1/3. Now, when I go to try to square root this, what we end up doing is square rooting a negative. Well, that would give us an imaginary answer. Therefore, there is no vertical asymptote. Now, for the horizontal asymptote, we need to look at the powers of the numerator and the denominator. So you can see this numerator has a power of 1. The denominator has a power of 2, which means the numerator is less than the denominator. So by our rules, when the numerator is less than the denominator, we have a horizontal asymptote at y equals 0. Now, moving on to the next one. Same thing. We're going to find the vertical asymptote, and then we'll find a horizontal asymptote. And sometimes there aren't any, as you can see in that first one, and there are sometimes not any horizontal asymptotes as well. Just depends on the problem. So the vertical asymptote, once again, is solved by setting the bottom equal to 0, and then solving. So we'll add 1 to both sides, and then I'm going to square root. And what I end up with here is plus or minus 1. So what that means is this particular graph will have two vertical asymptotes. One will be at x equals 1, and one will be at x equals negative 1. Now for the horizontal asymptote, we are going to look at the powers of the numerator and the denominator. In this case, the power of the numerator is 2 and the power of the denominator is also 2. Therefore, they are equal, which means we divide the lead coefficients, meaning what is the number in front of the x squareds. In this case, it is 2 divided by 1, which would be 2. So our horizontal asymptote then will be y equals 2. So as you can see from this graph, this one ended up having 3 asymptotes. It had 2 vertical asymptotes and 1 horizontal asymptote. Now, if you look at the graph of the first one, you can see that as this graph would extend, it would start to flatten out, and this graph would extend, it would start to flatten out, and there is a horizontal asymptote right there. But there's only one, and that's what we figured out from here. There's a horizontal asymptote at y equals 0, but there was no vertical asymptote. Now, if you look at the second one, you can see we had 2 vertical asymptotes and 1 horizontal. If I go to that graph, you can see them there as dashed lines. There are 2 horizontal asymptotes right here and right here, and there is one, sorry, I said that backwards. There's 2 vertical asymptotes, and then there is 1 horizontal asymptote. So here's a couple more that we want to try. It says find all vertical and horizontal asymptotes of the following. So procedure is still the same. We'll start with vertical asymptote because you always just simply set the bottom equal to 0 and then solve it. Now in this case, this is a quadratic. We should try to factor it first, which it will factor. It factors into x minus 3 and x plus 2. And so when I set each part equal to 0, you can see that I end up getting 2 vertical asymptotes. X equals 3 and x equals negative 2. Now, as far as horizontal asymptotes go, we need to look at the powers. And because the powers are equal, they're both 2, we have to divide the lead coefficients. In this case, both of them have a lead coefficient of 1. So when I divide 1 divided by 1, I get 1. So the horizontal asymptote is y equals 1. Now the last one we're going to try, we will also find the vertical asymptote and the horizontal asymptotes. And same thing, set the bottom equal to 0 first. X squared plus 4x plus 3 equals 0. This one will factor as well. You can see we need 2 numbers that multiply to give me 3 and add to give me 4. So it will be 1 and 3. And then we simply set both of these equal to 0 and solve. So there are our 2 x values. So those are the 2 vertical asymptotes as well. Now, horizontal asymptotes are done by looking at the powers of the numerator and the denominator. The numerator power is 3, the denominator power is 2. And since 3 is bigger than 2, when the top is bigger than the bottom, there is no horizontal asymptote. Okay, so that's what I have for you today. I hope that made sense. As always, if you have any questions, feel free to email me. Have a great day.